We all know salt dissolves in water. Let's find out why.
I shall now explain how table salt dissolves in water. First, we have the water. Chemical equation known as H2O, represented here by the hydrogens and the oxygens. When we introduce table salt, also known as NaCl, to the water will break apart this molecule and by using hydrogen bonds attach itself to the hydrogens because the chlorine is negative and the hydrogens are positive and the opposites attract. Whereas the sodium breaks off and attaches itself by hydrogen bonds to the oxygen for the same reasons.
Well, since salt dissolves in water, why doesn't Bob and these kids dissolve? So Bob, why do you think it is you didn't dissolve?
I don't know, because I'm not a polar molecule.
What Bob said was correct. Water, since it is a polar molecule, dissolves ionic and other polar molecules. But Bob, a mixture himself, is protected by a non-polar covering. Therefore, he did not dissolve in the water. Also, why did these two kids playing not dissolve either in the air? Also, why aren't these mouthpieces dissolving when these two musicians are playing them? It's because of the same rule that was presented earlier, the like dissolves like. With the mouthpieces, the solids are not of the same solubility as the saliva in their mouth, therefore they do not dissolve. Same with the ping pong table and the air. This all happens because of the major solubility rule. Like dissolves like. For example, polar dissolves polar and ionic. Non-polar dissolves just non-polar. And ionic dissolves just ionic. Here are some other solubility rules. All common compounds of group 1 and ammonium ions are soluble. All nitrates, acetates, and chlorates are soluble. All binary compounds of the halogens, other than fluorine, with metals are solubles, except those of silver, mercury, and lead. All sulfates are soluble, except those of barium, strontium, calcium, lead, silver, and mercury. Except for the first rule I mentioned, carbonates, hydroxides, oxides, silicates, and phosphates are insoluble. Sulfides are insoluble except for calcium, barium, strontium, magnesium, sodium, potassium, and ammonium. Those are the 6 major solubility rules.
Now we will put some salt into each of the containers. One of them is hot, which has been microwaved for a minute, and the other which has ice in it. You see, Bob's putting salt into the cold one. Okay, that's good. Now he will put some into the hot one. As you can see, he put now, as you can see in the hot one, approximately the same amount of salt, which was pre-measured, was put into each container. As you can see, the hot one has dissolved more than the cold one has. This just proves that hotter temperatures do dissolve more than colder temperatures. During this project, we learned a lot. We learned that solubility follows the major rule, like dissolves like.
We've also learned that some compounds may conduct electricity as they dissolve by releasing free-floating ions within the substance.
For example, the salt water.
Yes, the salt water.
We had a lot of fun doing this project. We got to use a computer to edit our tape.
Overall, this project showed us many things, and we had lots of fun doing it.
This project was done by Graham Hogginson
And lots of
Thank you. Goodbye.